In our last video, we looked at the basics of Gauss Jordan elimination. And we did that using a two-variable, two-equation system. Gauss Jordan is really the most useful when you're looking at systems of equations with 3 or more variables. So we're going to write down our steps, and these model the steps that we used in the previous video. So if you have not watched that video, I suggest you back up and you watch the introduction to the Gauss Jordan method video before you watch this one. All right, so we saw in that video that our first step was to rewrite the system as a matrix. And that just makes our computations easier where we don't have the x's and the y's and the equal signs. Then we are going to get a 1 in row 1, column 1. Then we are going to get zeros everywhere else in column 1. So both of these steps are getting column 1 the way that it should look to be able to read my solution. Then we'll move to column 2, and we will get a 1 in row 2, column 2, moving down the diagonal. And then we will get zeros everywhere else in column 2. And it's very, very, very important that you follow these steps in exactly this order so that you don't mess up what you've done behind you. And then we will move to the third column, get a 1 in row 3, column 3. And then, once we've gotten that 1, we will get a 0 everywhere else in column 3. And notice I'm kind of color coordinating this. Get a 1, get a 0, get a 1, get a 0, get a 1, get a 0. And we're actually going to see that we're going to have to get 2 zeros each time, but we're doing the same thing every time. And we're always going to get a 1 by multiplying by the reciprocal of the number we're trying to get to be a 1. So if it's 5, we multiply by 1/5. If it's 2/3, we multiply by 3/2. If it's negative 3/4, we multiply by negative 4/3, and so on, because that gives us a 1 every time. To get a 0, we're going to use the elimination method. And we're going to see that the elimination method is to multiply the row where you just got the 1 by the negative of the number you're looking for, of the number you're trying to eliminate. Because if you add 5 and negative 5, you get 0. 2 and 2/3 and negative 2/3 is 0. Negative 4/3 and positive 4/3 is 0. So for this, we're eliminating by adding. So we're multiplying by the negative of the number we are eliminating. and then add back to the row that's changing. So we are always multiplying and adding. All right, that's a lot. That's a lot to look at here. So hopefully you have looked at the video, the previous video, and you at least have kind of an idea of what we're talking about here. And I did forget the 8th step here, and this is important to do this last 8th step, is to actually write your solution. Write your solution when you're done. All right, let's do this. And we're going to do this trying to keep a fairly organized system. And I have found that it is very helpful to do these if you just divide your paper in half long ways. You can either fold it in half, you can mentally do it, you can actually draw a line the way I did, and then you're going to put all of your matrices on the left, and you're going to put all of your row operations on the right. And you're going to do all your arithmetic and finding your new rows on the right, so that your matrices are one right after the other and very clear and easy to see. So let's say that we have this system 4x minus 3y plus 2z equals 1, and 2x plus 4y minus 5z equals 11, 3x minus 3y equals negative 3. Now, if we look back, our first step is to write this as a matrix. So I'm going to actually try to have you stay one step ahead of me as we're working this example. So you're going to be pausing your video quite a bit and then starting it back up. Do not just blindly write down what I'm writing down. Try at each step to think about what's going to happen next and try it yourself. At first, this is very confusing, but once you've gone through all of the steps, you're going to see that you are just doing the same thing over and over. It's very repetitive. So the first step, write your matrix. Pause your video, write your coefficients, then restart the video. All right, my first column represents my x's, and I do find this easier to do by column. You can do it by row or by column, whichever you like. I prefer to do it by column. So the coefficients of my x's are 4, 2, and 3. The coefficients of my y's, and it's important you put the negative. If you have a negative coefficient, you must put a negative number. And then on my z's, notice in the last equation, I don't have a z there. That means the coefficient of z is 0. So I must have a number in every spot. And then my constants are 1, 11, and negative 3. Okay, let's think back to our steps. Our very first thing we want to do is get a 1 in row 1, column 1. So I'd like you to draw a box to represent getting a 1 around the number that needs to be a 1. And I see that row 1, column 1 is right here, so I need a 1 in this spot. And I remember to get a 1, what I do is I multiply that entire row, and notice I'm writing this line right here. That's where I'm going to write my row operation that tells me what I'm going to do to get that 1. And I'm going to multiply by the reciprocal of this number, multiply that whole row. So you write your row operation. And that would be 1/4 times row 1. And then I can come out here to this side, and I can actually do 1/4 times row 1. And this will give me my new row 1. You go ahead and do that work. Pause the video, do that work, then rewrite the new matrix with the new row 1. Do not change row 2 and 3 at this point. Go ahead and recopy them, and then restart the video. So I multiply by row 1. I get 1. 2 over 4 is 1/2. And that's my new row 1, so I rewrite row 1. And then I recopy row 2 and row 3 exactly the way they were. And now I'm ready to move to the next step, which will be to get zeros everywhere else in column 1. I got a 1, row 1, column 1. Now I need zeros everywhere else. I'd like you to circle the numbers that need to be zeros. So I'm going to circle here and here. And we're going to go ahead and write our row operations for both of those. And go ahead and do those, both of those over here on the right, and then rewrite the new matrix. So I have to think about getting a 0 is the elimination method. I am going to multiply and then add. I'm always going to multiply the row where I just got the 1. So for both of these, I will be multiplying row 1 by something. And what I'm multiplying by is the negative of what I'm changing here. So I'm going to multiply by -2 times row 1, and then add that back to the row that's changing, row 2. I'd like you to try to write your O operation for eliminating the 3. Pause the video, write that row operation, and then we'll look at actually doing those row operations. Okay, so since I have a 3, I'm going to multiply row 1 where I just got the 1 by -3, and then I'm going to add it back to the row that's changing, row 3. And now I can go ahead and do those. I'm going to draw a line there to separate. I can do that row operation. I'm going to do this first one for you, and then I'm going to have you do the second one. I'm going to take -2 times row 1, and I always look back at the row 1 I have here in the matrix. And I recopy that. And I do that step first. I go ahead and do the -2. And then -2 times -3/4. The negatives cancel, the 2 and the 4 cancel, so I have 3/2. -2 times 1/2 is -1. -2 times 1/4 is -2/4, which is -1/2. So all I've done so far is multiply row 1 by -2. Now I add row 2. And notice -2 plus 2 is 0, which is exactly what I wanted. That's why I did this specific row operation. Then 3/2 plus 4, 4 is 8/2. So 3/2 plus 8/2 is 11/2. -1 plus -5 is -6. -1/2 plus 11, 11 is 22/2. So -1/2 plus 22/2 is 21/2. And I would think it's going to be useful and beneficial for you to learn how to use fractions, multiply and add fractions. But if you must use your calculator at this point, that's fine. Just go ahead and write your numbers as fractions, not as decimals. So this is my new row 2. But I'm not going to, at this point, rewrite the matrix. I'm going to go ahead and do my second row operation here. The -3 row 1 plus row 3. And I'd like you to go ahead and do that. I want you to pause the video, model what I've done. -3 times this row 1, we're always using that original row 1 here, plus row 3, and that will give me my new row 3. Then I can rewrite the matrix, recopying row 1, putting in my new row 2 and my new row 3. So pause the video, do that, rewrite the new matrix, and then join back. And I see that I have -3 row 1. So I multiply. Negative times negative is positive. So that's -3 row 1, and now I add that back to row 3. And this is going to be my new row 3. And notice -3 plus 3 is 0, which is what I wanted. -3 is the same thing as -12/4. So 9 fourths minus 12 fourths is -3/4. And -3 is the same thing as -12/4. So that is -15/4. And this is my new row 3. So I rewrite my first row. And then I rewrite my new row 2. And my new row 3. It's very, very, very important I watch my signs. I don't make any careless errors, or I'm just going to have a mess moving forward. All right, we are done with column 1. We got our 1, we got our zeros. Now we move to column 2, and we're going to duplicate what we did, just putting it in a little bit different order. So I'd like you to draw a box around the number in column 2 that needs to be a 1. And we see that it's row 2, column 2, so this needs to be a 1. And to get a 1, we multiply. Notice I'm writing my line out here beside the row that's changing. That helps keep me organized. So I want you to write your row operation here. And remember, to get a 1, you multiply by the reciprocal. So we're going to multiply by 2/11 times the whole row 2. So I'll go over here to the side and I'll do that. 2/11 times row 2. And remember, to multiply fractions, you multiply the numerator, multiply the denominator, and if you don't have a denominator, it's an understood 1. So I have 0, and then 2/11 times 11 halves. The 2's cancel, the 11's cancel, and we get 1, which is why we multiplied by that. And then we have -12/11, and then my 2's cancel, and I have 21/11. And this is my new row 2. And I go ahead and rewrite my matrix. Do not try to get your 1 and get your zeros at the same time. Get the 1, write a new matrix, then move forward getting your zeros. So row 1 didn't change. My new row 2. and row 3 did not change. All right, now we have our 1. We're ready to move forward with getting our zeros. I want you to identify which ones need to be zeros, circle those, and write your row operations. And then check and see if we have the same thing before we move on. So I see that I need a 0 here and here, above and below the 1. And now we're working in column 2. We just got our 1 in column 2 in row 2. So that means that we're going to multiply by row 2 in each case and then add back to the row that's changing. So if you haven't written those row operations yet, go ahead and do that now. We're going to multiply by the negative of the number we're making a 0. We have negative 3/4, so we're writing positive 3/4. And then we're multiplying, adding back to the row that's changing, row 1. Then we're looking at negative 3/4, so we put a positive 3/4, and we add back to the row that's changing, which is row 3. You go ahead and do both of those row operations over in the margin. Do 3/4, row 2 plus row 1, and also do 3/4, row 2 plus row 3. Find your new row 1 and your new row 3. Then write your new matrix. Pause the video, do both of those steps, write the matrix, and then start the video again. All right, so 3/4 row 2. Row 2. Let's see, 3/4 times negative 12 over 11. The 12 cancels with the 4. So I have negative 9 over 11. And then nothing cancels here, so I have 63 over 44. And now I add those two. I add that to row 1. And I have 1, 0, which is what I wanted. All right, negative 9/11 over 1/2. So I'm going to have to get the same common denominator here. So I'm going to have negative 18 over 22 and 11 over 22. And I have negative 7 over 22. And this one, I'll have 11 over 44. So 63 plus 11 is 74 over 44. That's my new row 1. Now I do the next one, 3/4 row 2. I go back to my row 2 from my matrix. Twelve and 4 cancel, so negative 9 over 11, and then 63 over 44. And I add that back to row 3 now, because I'm trying to get the 0 in row 3. Okay, I made a mistake here. Notice here 3/4 times 0, that should be 0. And I knew that I made a mistake because I was noticing when I added those numbers, I was not getting a 0, and I knew I had to have a 0. So 3/4 times 0 is 0. 3/4 times 1 is 3/4. All right, now I'm writing row 3. So 0 plus 0 is 0, which it needed to be, so I didn't change that 0 I'd already gotten. 3/4 plus negative 3/4 is my 0 I'm trying to get. And then negative 9/11 is the same thing as negative 18 20-seconds. And negative 3/2 is negative 33 20-seconds. So negative 18 and negative 33 is negative 41 over 22. And then I think I'm going to pull my calculator out for this next one. You're very welcome to use your calculators if you wish. So I'm going to double check my negative 9 divided by 11 plus a negative 3/2. And I hit math, frac, enter, negative, yeah, see I made a mistake there when I added that. It should have been negative 51/4. Negative 51 over 22. All right, and let me go ahead and use my calculator for the next one as well. So I have 63 over 44 minus 15 over 4. And I hit math, frac, and I get negative 51 over 22. And this is my new row 3. So let's go ahead and write our new matrix. So my first row, notice labeling here. This careful labeling helps me when I go back. I have 1, 0, negative 7 over 22, and 74 over 44. My row 2 did not change. And my new row 3 is negative 51 over 22, negative 51 over 22. So I'm done with column 2. Column 2 usually tends to be the most difficult column, where you start having a lot of messy fractions. Once I get my 1 in the third row, then the computations are usually not quite as difficult for the third column. I want you to see if you can actually finish this problem yourself. I want you to see if you can get your 1 here, row 3, column 3, by multiplying by the reciprocal. And then in the next step, get your zeros above it. Write your row operations. Do your row operations and write your new matrix. I want you to see if you can do that yourself. Look back at what we've done in the previous rows, previous columns. Try that yourself and then check back with the work here. So pause the video, do that work, and then restart the video. All right, I need to get a 1. So I multiply by the reciprocal. The reciprocal of negative 51 over 22. I flip the fraction, but the sign does not change. So that would be negative 22 over 51 times row 3. Because a negative times a negative is a positive 1. So I'm going to do negative 22 over 51 times row 3, negative 22 over 51 times, and if you can just do this in your head, that's fine. You don't have to actually write this step out, but I just want to be sure we're clear what's going on. We get a 0, we 0, and then the 51s cancel, the 22s cancel, negative times negative is positive. And then we have the same thing, so we get a 1 again, and this is my new row 3. So my first row did not change. My second row did not change. And now my third row is where it needs to be. And notice we already have what z equals. Z equals 1. And at this point, you could back substitute. And some of the instructions in the My Math Lab show that. But I'd like you to go ahead and just do your last 2 row operations. Completely finish this out and get x equals, y equals, and z equals. So I need to have a 0 here and a 0 here. And remember that I multiply by the negative of what I have. So I'm going to multiply by positive 7 over 22. And what I'm multiplying by is row 3, where I just got that 1, and then adding it back to the row that changes. And then here I have negative 12 over 11, so I multiply by positive 12 over 11, also by row 3, where the 1 is that I just got. And then I add back to the row that's changing, row 2. So I'm going to go over here on the left-hand side, and I'm going to do those 2 row operations. Times 0 is 0. And then times 1. And we're going to add that to row 1. And notice 7 over 22 minus 7 over 22 is 0, which is what we were trying to do. And then 7 over 22 plus 74 over 44. Let's see, 14 over 44. 14 would be 88. 14 plus 74 is 88 over 44, which is 2. And this is my new row 1. And if you use your calculator for that, that's fine. Let me double check that with my calculator. And we do have 2. All right, let's go ahead then and do our last row operation here. And I'm going to go ahead and do it here rather than continuing on down on the right, just because I'm running out of room here. So I'm going to have 12 11ths, row 3, plus row 2. So I have 12 11ths times row 3, plus row 2. In row 2, and I add that, 0 plus 0 is 0, 0 plus 1 is 1, 12 11ths minus 12 11ths is 0, 12 11ths plus 21 11ths. Since I have the same denominator, I can just add the numerators. 12 plus 21 is 33, 33 over 11 is 3. And this is my new row 2. So I can write my new matrix. my first row, my second row, and my row 3 didn't change. And now I see that I have this exactly the way I need it to be. So I can write my ordered pair, x equals 2, y equals 3, z equals 1. Now, this process is tedious, but I do want you to be aware that you are doing the same steps over and over. And once you grasp the concept of where the ones go and where the zeros go, and how you can get a 1 and how you can get a 0, from there is just number crunching. And it comes down to being neat and organized. And you are welcome to use your calculator to do your addition. And when you get to the end, don't forget to write your solution. This is the process that I'm going to expect to see on a test. When I ask you to solve a problem using Gauss Jordan elimination, this entire process is what I expect to see. I do not expect to see plug the matrix in, press a couple of buttons on the calculator, and it spits out an answer using some program on the calculator. I need to see your row operations. I need to see your work, and I need to see your final answer.